This video is going to go through how to create distance time graphs. So our first example here, we have a helicopter leaving Bristol at 10 a.m. It flies for 45 minutes at 80 kilometres an hour. So 45 minutes is the time and 80 kilometres per hour is the speed. So we need to work out how far it flies. So this means we need to find the distance. So distance equals speed times time, which means our speed is 80 and our time is 45 minutes, which is 3/4 of an hour. So it's 80 times 3/4, which will give us 60 kilometres. It then lands for 30 minutes and then flies a further 65 kilometres in 30 minutes. The helicopter then immediately returns to its base in Bristol, flying at 100 kilometres an hour. So this here is the speed, and we know the distance because it flew 60 kilometres and an additional 65. So it's currently 125 kilometres away from the base. So we need to work out, well, how long is that going to take? So we need to find the time. So time equals distance over speed, which will be 125 over 100, which will give us 1.25, or 1 hour and 15 minutes. We then need to graph this. So on our graph to the right here, you need to label your axes. So we'll start here with our time. So we've got 10 a.m, 11 a.m, 12 a.m, 12 p.m, 1 p.m, 2 p.m, 3 p.m, and that's time. And then on our y-axis, which is our vertical axis, we'll put our distance, and we're going to go up in 20s. We've got 20, 40, 60, 80, 100, 120, 140, 160, and 180. And this axis here is distance from Bristol. Now, if you had more space, you'd put that alongside the axes, but just due to space here, I've just put it at the top. You then need a title. So this is a graph showing the distance travelled by a helicopter. So we'll call it the helicopter journey. So we start at 10 a.m, so that's currently 0 kilometres away. We then fly for 45 minutes at 80 kilometres an hour, and we worked out that that distance was 60 kilometres. So after 45 minutes, so half an hour would be at this point here, 45 minutes would be here, we've travelled 60 kilometres, so we can put a point there. Sorry. It then lands for half an hour. So to show you that it's currently on the ground, what you do is you have a horizontal line. The horizontal line shows that the plane is currently not moving, it's stationary. It then flies for 65 kilometres in half an hour. So from 60, 65 kilometres will be 125, and that happens in half an hour. Then we can mark that point. It then returns immediately back to its base, flying at 100 kilometres an hour. So flying at 100 kilometres an hour, we worked out that it takes an hour and 15 minutes. So 15 minutes will take us to 12. So that means that it will be back by 1 p.m. You then need to join all of these dots with straight lines to show the actual distance time graph. So then that there shows the helicopter journey from Bristol. Our second example shows Thomas's journey. So I've already created the graph for you. You can see scaled axes here going up in 20s for the distance from home, and then the scaled axes on the X is going up in hours of time starting at 2 o'clock because that's when he leaves home. So you can already have a point at 2 o'clock to show that that's when he's left home. He drives at an average speed of 40 miles per hour. For 3.5 hours. So we've got the speed and the time, so we need to find the distance. So distance equals speed times time. Here you've got 40 miles per hour times 3.5 hours, which will give you 140 miles. So in 3.5 hours, he travels 140 miles. So 3.5 hours after 2 o'clock is 5:30. So at 5:30, he'll be 140 miles from home. So you go up your 5:30 line to 140. So we mark that point. It then says that he stops for 30 minutes. So that means we've got a horizontal line, 30 minutes. So that's going to be 1 block away. So we draw another dot. Sorry, guys. Half an hour away. He then drives home at an average speed of 70 miles per hour. So we know that he's 140 miles from home, so we know that D is 140 and his speed is 70. So we're trying to work out how long it will take him to get home. So time equals distance over speed. So we've got 140 divided by 70, which means it's going to take him 2 hours to get home. So 2 hours after 6 o'clock is going to be 8 o'clock. So at 8 o'clock, he will arrive home. We then join all of those points with straight lines, and you'll get your distance time graph for Thomas's journey. Our final example is Erin going on a cycling journey. So the first thing you can do is put a title on your graph for Erin's journey, and then you can create your scaled axes with axes titles. So once you've got your scaled axes, in this case we've gone up in 4s on the y-axis for the distance, and then we've gone up in half an hour increments for the time on the x-axis. We then need to work out where each of our points are going to be on this graph. So she leaves home at 11 a.m, so we know that the distance from home at 11 is going to be 0. She then cycles at a speed of 16 miles per hour for 90 minutes. So we've got speed and time, so we need to work out the distance. So distance equals speed times time. So in this case here, we've got 16 times 1.5 because 90 minutes is an hour and a half, and that's going to give us 24 miles. So after leaving home, an hour and a half later, which will be at 12:30, she's going to be 24 miles from home. So we show that with a point on our graph. She then stops for half an hour. So she's going to have a horizontal line for half an hour. So from 12:30 to 1 o'clock, she's stationary, so she's still going to be 24 miles from home. And then she cycles home and arrives at 3 p.m. So we know that she gets back at 3 p.m, so we can put a dot there. We can then join these dots to show our distance time graph, and that's created the distance time graph. It then asks us to determine the speed on the return part of her cycle. So to work this out, we need to know what is the distance and the time. So we know that she was 24 miles from home, so D equals 24, and we know that it took her 2 hours to get home because she left from her stop at 1 o'clock and she got home at 3 o'clock. So we know that D equals 24 and T equals 2. So to find the speed, we need to do distance over time. So then our distance is 24 and our time is 2. So we know it's going to take her, or she's going to ride at a speed of 12 miles per hour to get home.